Hey, Physics 30. So I'm just going to go over the wave model assignment number 2 here to give you some solutions. Practice for the quiz coming up. So we have a 5 centimeter tall object that is placed 10 centimeters in front of a concave mirror that has a focal length of 8 centimeters. Okay, this sounds familiar. It sounds like we've done this question already, but maybe. They all seem to repeat after a while, but if they haven't, that's fine. Let's just go over this one. So what do we have? So we have the HO. Remember, the HOs are always positive. I'm just going to ignore my sig digs for now. It's placed 10 centimeters in front of a mirror, so that's my DO. We have a concave mirror that has a focal length of 8 centimeters. I'm just going to emphasize that's a positive number. They just want us to help us find the distance, the height, and the magnification and any of the attributes of this image. Okay, so let's set up the formula here to find my DI. So my D 1 over DO plus 1 over DI is equal to 1 over F. So if I rearrange this for DI, I'm going to have 1 over F minus 1 over DO. So I'm just going to minus over that whole fraction. I'm going to put in the numbers here. So I have 1 over 8 minus 1 over 10. I'm going to end up getting a positive number here. And I'm going to go 1 over my answer. So I get a DI of positive 40 centimeters. Because that's going to help me with my attributes later because you got a positive piece here. So maybe I'll put a little attribute side over here. We have a real image. Since my DI is a positive number, makes sense. Let's find out what the magnification is. So I can find out my height. So I'm going to go negative DI over DO, and we have these two numbers now. So negative 40 over my DO of 10. So this is going to be negative 4 times. Okay, so there's one of my things. And what I know is that the number is bigger than 1, so I know that this is going to be an enlarged image. Okay, it's negative, so I also know that it's inverted. Okay, now we're going to use this magnification to solve for my, there we go, to solve for my HI, image height. So my HI is going to be magnification times my HO, which is going to be negative 4 times my height of my object, which is 5 centimeters. I'm going to get negative 20 centimeters. And there's my HO. Yeah, I think we're good. What was I missing something here? Real, inverted, diminished. Or I can't think of, I know there's a fourth one. The fourth one is the position. Yeah, okay. Sounds pretty cool. Let's try this next one here. So we got a convex mirror. So a convex mirror, remember, is a negative focal length. It has a radius of curvature of 1 meter. So that means the focal length is always a half of the center. So it's always half of the radius. So my focal length is going to be negative, because it's convex, of 0.5 meters. So it's half of that radius. Because the radius of curvature goes to the center. Right? It goes to the center, so that means my focal length is going to be half of that. How tall would the image be if a 1.5 meter tall man is standing 5 meters from the mirror? Okay, so this is the information that we have. So what I'm going to do now is I'm just going to find out my D. We're going to find my DI before I can find my DO. So I'm going to find my DI first. So I'm going to set up my formula. Rearrange it for my DI. So that means I'm going to take 1 over F minus 1 over DO. I can put some information in there. We have negative 0.5 on that first part minus a 1 over 5. Okay. We do that, we can find our DI. Our DI, it's going to be a negative number, it looks like, so that's fine. Then we go 1 over my answer here. So our DI is going to be negative 0.4545, repeating. That's not exactly what I wanted to find. I wanted to find the height. So what is my height of my image? So I'm going to use part of the magnification formula that involves not finding the m. So I'm just going to use this part. I'm going to put in the pieces that we know, but we're trying to find hi. So I'm going to times up the HO. And I'm going to put all my numbers in there. I got my number in my calculator for my DI, so negative DI times my HO divided by my DO. So the person in the convex mirror is going to be positive. Okay, makes sense. It's convex. There's also a negative distance, so it's a virtual image, which also makes sense. 3 sig digs. So my HI is going to be 0.164 meters there. Okay, so let's do the next one here. Can't see. So we want to determine what is the focal length of this mirror and what is the type of mirror. So hopefully if I find the focal length, that'll just tell me what the type of mirror is, because positive means concave and negative means convex. So let's get at this here. So we know the HO is 3 centimeters tall and produces a HI that is 2 centimeters tall. Okay, produces a virtual image, which is going to be useful to help us figure this out, which I know that means that the distance to the image is a negative number, and they also just tell us that it's 2.50 centimeters, because it's negative because it's virtual, right? So we need to find out what the D or the F is. So that's my goal, is to find out what the F is. To find the F, I need to know what the DO is. We have the DI, I got to find the DO. So I'm going to use this information here to help me figure out what the DO is. And I know the DO is supposed to be a positive number. That's going to be key to solving this question. The DO has to be a positive number. Okay, so I'm going to use this formula to help me figure this out. So I'm going to put in the numbers that I know. So I know that I have a negative DI. So negative 2.5. So I know there's going to be a positive 2.5 on the top. We'll just emphasize that it's positive. I know this number on the bottom is supposed to be positive. I got to figure out how do we achieve that. Actually, it probably doesn't really matter. We just know it has to end up being positive. So I'm just going to put my other numbers on this other side here. 2 over 3. I don't have to do anything with this, apparently. 2 over 3. Yeah, looks pretty good. So I'm going to rearrange this for my DO on the bottom here. So I'm going to times that. Yeah, I'm going to times that 3 up. Divide the 2 down. I'm going to get a DO of 3.75 centimeters, specifically positive. Hopefully I didn't get a negative out of there, but we needed to get that DO to be positive. Then we're going to take that and put it into this formula here. So 1 over this 3.75 plus the 1 over negative 2.5. So you got to put the negative back in there. I'm going to go 1 over this answer that I have in my calculator. So 1 over plus the 1 over negative 2.5 there. I'll get a negative number, okay? So I get a negative 7.5. Everything was in centimeters, so we'll just leave it as centimeters there. I've got 2 sig digs. And because of the negative, this is a convex mirror. Okay, hopefully that prepares you for this quiz. It's coming up, pretty short little guy. So have fun. See you in the next video. Bye.